New videos from ESA space probe flying past the sun are truly out of this world. And this is the south pole of the sun. Earth, of course, is at the 9 o'clock position there in that black circle, as you can see, Earth to scale. This is not the whole sun, it's just the south pole of it. The spacecraft looping around the sun made its first close approach and filmed the encounter with its glorious image. It's the European Space Agency ESA solar orbiter. It entered close to the sun, known as perihelion, March 26, and coming in at a distance of about 48 million kilometers or 30 million miles, and it's inside the orbit of Mercury. At that area, temperatures reached around 500 degrees Celsius, that's 930 degrees Fahrenheit, and future perihelion is expected to get even closer and, of course, even hotter. It's swooping around its orbit. The spacecraft saw the sun as we have never seen it before, including the mysterious feature nicknamed a hedgehog and detailed views of the usually hidden solar poles. And as we see, this is the South Pole. These new observations taken with solar orbiter's 10 scientific instruments work for the first time and provide the data for teasing out the behavior of the sun. It includes wild magnetic fields and sometimes chaotic weather blasting out into interplanetary space. And we already saw the spectacular high-resolution image of the spacecraft from the spacecraft as it made its close approach. ESA now released a video of the encounter for a solar probe view of our star. And there's more videos if you want to see here in the article I leave below. The solar orbiter set to make the difference to solar science, not least because it shows us parts of the sun we can't really see usually. Because the Earth's the vantage point in orbit around the sun equator, its poles are extremely difficult to study. Only a spacecraft orbiting above and below the sun can see these areas. The polar regions are thought to be extremely important regions for the solar magnetic fields. They play a huge role in solar activity. But because the poles are so hard to see, we don't know what happens to the magnetic fields of the sun. And with this suite of instruments, Solar Orbiter offers unprecedented insight into these mysterious regions. Its view of the south pole of the sun on March 3rd revealed a region seething with looping magnetic field lines arcing away from the sun. The solar hedgehog is another fascination. It was captured March 30th, and solar physicists are yet to figure out exactly what it is and how it formed. It consists of a relatively small region, about 25,000 kilometers across, imaged in extreme ultraviolet to reveal the activity there. And what activity? It's hot and less hot spikes of solar gas are sticking out in all directions into the solar corona or atmosphere like solar bedhead. And the images are really breathtaking, according to what physicist David Bergams of the Royal Observatory Belgium says. He says, even if the solar orbiter stopped taking data tomorrow, I would be busy for years trying to figure out all this stuff, he said. Solar Orbiter's main goal is to help scientists understand the effect the sun has on the entire heliosphere, or the sphere of solar influence defined by the solar wind, whose boundary lays out beyond the orbit of Pluto. That solar wind blows particles and magnetic fields out into the interplanetary space, tangling with the planets with tangible effects. And the closer a solar orbiter approaches the sun, the better it will be able to sample how the solar wind acts and blows. It drew near perihelion March 21st, detecting an outflow of energetic particles, and even from this distance, the detection was revealing. The more energetic particles arrived first, followed by the less energetic ones. This suggested that the particles were not produced near solar orbiter's position, but close to the surface of the sun. Other instruments picked up solar events that could have produced the particles, accelerating them out into space, including a solar flare and coronal mass ejection, not dissimilar to a CME observed by the spacecraft March 10th. The sun is right now quite active. It's getting into its solar cycle 25, which means the spacecraft is going to be beaming home absolute bucket loads of valuable data in solar activity. It's at least 14 more perihelions scheduled for 2030, in which it'll swoop as close as 40 million kilometers from the Sun, using Venus flybys to boost speed as it whirls around. This first perihelion is rich with new data and observation and is tantalizing taste of solar bonanza, which will come. The ESA project scientist for the solar orbiter, physicist Daniel Muller, says we're still so thrilled with the quality in the data from our first perihelion. It's almost hard to believe that this is just the start of the mission. We're going to be very busy indeed, they said. This is on Science Alert by Michael Starr. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.